don't know why this is not working today. Okay, now it's working. Good. And now I'm a few minutes behind schedule, but that's alright. Okay, small crab challenges you to a game. The crab is going to mix up some cups and you have to predict where they'll end up. The cups will be arranged in a circle and labeled clockwise. Puzzle input. For example, if you're labeling where 3, 2, 4, 1, 5, there would be 5 cups in the circle. Going clockwise around the circle from the first cup, the cups will be labeled that. Before the crab starts, we'll designate the first cup in your list as the current cup. The crab is going to do 100 moves. Each move, the crab does the following actions. The crab picks up the 3 cups that are immediately clockwise of the current cups. They are removed from the circle. Cup spacing is adjusted as necessary to maintain the circle. Crab selects a destination cup, the cup with a label equal to the current cup's label minus 1. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. If at any point in this process the value goes below the lowest value, crabs round to the highest value on any cup's label instead. The crab places the cups it just picked up so they are immediately clockwise of the destination cup. They keep the same order as when picked up. The crab sets a new current cup. For example, switch your cup. Crab would do maybe 10 moves. Cup 1. Okay, picks up current cup. Pick up 891. Label equal to the current cup's label minus 2. Destination 2, and then put them to 891, and so on and so forth. Do this. Crab is done. What order will the cups be in? Starting after the cup labeled 1, collect the other cup's labels clockwise into a single string with no extra characters. Each number except 1 should appear exactly once. In these episodes, we simulate 100 moves. What are the labels on the... Okay. So we don't actually need this for now, and we'll just say raw equals this. Okay, so let's think about this, because we want to insert arbitrarily and alright, so what do we call this? Let's call it a cup game. Class cup game. And we will init it with some cups, which are a string. And we're going to do 2 things. Self.cups equals int c for c in cups. Self.low equals min of self.cups. Self.high equals max of self.cups, because it says I'm going to want to use these things. And it will designate the first cup in your list as the current cup. So I'll say self.index equals 0, and I'll just work with the index. And let's, and I may rethink about how I want to model this, but for now I'm just going to leave it and say each move is the following. Picks up the 3 cups that are immediately clockwise of the current cup. So, you know, this might be easier if I use a queue, and so I will maybe do that. Self.cups equals the queue with this in it, and now I don't need a self.index because the self.index is going to be as follows. Let's say current equals self.cups.pop left, and now C1 equals self.cups.pop left, C2 equals self.cups.pop left, C3 3 equals self dot cups dot pop left, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's fine. So I pull off those 3 and choose a destination cup with a label equal to the current cup's label minus 1. And so let's say destination equals current minus 1. And let's say remaining equals a set of self.cups. I'll just do that. Destination equals current minus 1. While destination not in remaining. So if it's not there, keep subtracting until it finds a cup that wasn't just picked up. Or let me do it this way. Let's just say missing equals C1, C2, C3. While destination in missing, destination minus equals 1. And then if destination is less than self.low, destination equals self.high. Okay, and now we have, that's good. Now rotate to get to destination, and immediately clockwise of the destination cup. So 891 go to 2, and so while cup equals self.cups.pop left, while that is not equal to destination, pass, or let's say while true, cup equals self.cups.pop left, if cup equals destination, then break. Self.cups.append cup, so I want to move it to the end, and if it equals destination, stop, and once I stop, I want to self.cups.extend missing. That's easy enough. And let's see, I just need to check and see if I can randomly access elements. I can. Okay, and so while while self.cups 0 is not equal to destination, self.cups.append self.cups.pop left. Okay, and so now the current should be there. And so let's use their example and say, suppose the cup labeling were this. Raw equals that. and game equals cup game of raw, and let's say game.move, and let's run this. Game.cups, and now it should be 28915467, and then but I'm missing the 3, so I should have added that back. And when should I have added that back? And I will do self.cups.append current. Okay, so this is get the current cup and move it to the end. Take the next 3 and good. So let me try this again. And now let's do game.move and game.cups, and now it's 789132546, with 5 being the current one, but 5 is not the current one. So why is that? Destination 7. I think I read the instructions wrong. The cup selects a new current cup. The cup is immediately clockwise of the current cup. Okay, so that's the issue. And I don't want... Okay, now rotate to the cup after current. So again, while true, cup equals self.cups.pop left. If cup equals current, break. Okay, so now let's try it one more time and see if I got it right. Self.cups.append cup. All right, let's try it again. Okay. No, that's not right either. Okay, what did I get wrong? Let's try again. Okay. Why does this not even have the right thing in there? So self cups equals dec int c self low. Why is that? Game equals cup game raw. Game.cups. Okay, that's right. And now it's 289 whatever. Game.move and game.cups. And now it's 546789132. Game.move and game.cups is 89. Okay, so that looks good. Starting after the cup labeled 1 labels. So now let me say def labels self goes to a string, and let's say while true, cup equals self.cups.popleft. If cup equals 1, then return self. Let's say outstring equals no. Let's make it a list of self.cups. Type list int right stir I for I and list self.cups. And let's put it back now. Self.cups.append. Let me just do it this way. And okay, so let's try this one more time. And something is really bothering me about why this is not working. Hold on one sec. Why does it have... Oh, I know, that's why. Damn it. So I start after 1 and I go 2, 5, 4, 6, 7, 3, 8, 9. So that looks right. Okay. And now what does it say? 100 moves. Okay, so for blank in range 100 game.move and then assert game.labels equals this thing. Okay, and so now here we have this, and game equals cup game of raw for blank in range 100 game.move and print game.labels. Okay, so let's try it. Okay, well that's pretty broken. So let's figure out why it's broken. Print game.cups. And we'll figure out what I broke. While true, cup equals self-cup. Oh, I see what's going on. Destination equals current minus 1. So let's say while not destination in self.cups. That's not as efficient, but it probably will work. I think what was going wrong was that I was at 1 and I subtracted 1, it was at 0 and it wasn't, and it just kept subtracting 1, although still should have worked. Or no, it didn't work. Anyway, let's try it. that's the right answer. Due to what you can only assume is mistranslation, you were surprised when crop starts running many cups in a circle, 1 million in total. Your labeling is still correct to the first 2 cups. After cups, the remaining cups are just remembered in decreasing fashion, starting from the number after the highest number in the list, proceeding one by one until 1 million is reached. For example, if the labeling were 5, 4, 3, 2, 1, the cups will be numbered this way, and then start counting up from 6 until 1 million is reached. In this way, every number from 1 through 1 million is used exactly once. After discovering where you made the mistake, the card number should be the small crab is going to do merely 100 moves. This crab is going to do 10 million moves. This crab is going to hide your stars under the 2 cups that will end up immediately calling. You can have them if you correct what labels cups. For example, this would be. Okay, so obviously what I did is not going to work because it's not efficient. So this could be, there was one in a previous year where doing it long-handed would have been impossible. But so I start with, a bunch of numbers, and then I get big numbers up to 1 million. And then I start working it, and proceeding one by one until 1 million is reached. For example, if you're leaving where 5, 4, 3, 2, 1 the cups are numbered, and then start counting from 6 until 1 million. So every number is exactly once. A small crab isn't going to do, it's going to do 10 million moves. Okay, so obviously I don't want to do, a million times a million operations. That will take too long. And so what I can do is let's think about this and say, so let's define cup game 2 and think about it this way. Self.low, and then let's say for I in range, self.high 1,000,001, self.high plus 1, self.cups.append, or let's just say, do it this way, self.cups.append self range self.high plus 1, and this, and we don't want to append, we want to extend. Okay, so we extend it, and let's assert len self.cups equals 1 million, and self and I'm not even going to do this, equals range max self.cups equals 1. Okay. So we've got that covered. And now we need to be real efficient, which is so we are going to do a linked list, I think, instead of a queue. Because with a linked list we can insert and remove real quickly. So let's think about this now. Say cups equals int c for c in cups, cups.extend this, and all right, so how are we going to make this into a linked list? Python doesn't really have linked lists, but I can fake it by saying from, this might not work by the way, but we'll see if it works. Data class, class node, and let's say value is an int, and previous is a node, and next is a node. Okay, and so what I want to do is I want to say, so let's start with this and say self.ll so what do I want to do? So tail equals none. Boy, I haven't done one of these since I practiced for coding interview problems. And let's say, actually let me start this way. Cups equals NC for C and raw cups. Self.head equals actually no. What I want to do is I want to say initial equals cups 0 and self.nodes equals initial goes to node initial none none. It's getting mad at me because none cannot be a node. Okay, and so what do I want to do is I want to say prev equals this. Prev is node prev. Okay. For cup in cups 1, let's say self.nodes cup equals node of cup self.nodes prev and none. So add backlink to previous node, and let's say initial equals prev. And add forward link from previous node, self.nodes prev dot next equals self.nodes cup, so the one we just added, and now let's say prev equals cup. Okay, and now for I in range max cups plus 1, or let me just do it this way. Actually, let me do this. Import iter tools, so I don't have to write the logic twice. So for cup in iter tools dot chain, those cups plus range max cups plus 1, 1,000,001. There we go. And now add links between end and beginning. Self.nodes initial.prev equals self.nodes let's say cup, and self.nodes cup dot next equals self.nodes initial. So now it forms a loop, and we have lookups. And why cup is possibly unbound. Cup is not unbound. So that's a stupid error. And now what I want to do is I just want to assert that len of self.nodes equals 1,000,000. And what I want to do is and now I need to move. So I'm just going to copy this, and because it has the logic in it, even if it's not working right. And actually, let's say self.current equals prev equals cups 0. And then instead of initial, I'll say self.current, and instead of initial, I'll say self.current. Okay, good. So actually, so let's say current equals self.nodes self.current. Okay, and let's say n1 equals current.next, n2 equals n1.next, n3 equals n2.next, and v1 equals n1.value, v2 equals n2.value, v3 equals n3.value, and let's say rest equals n3.next. Find next 3 nodes, get their values, and remove them. So, and the way we remove them is by saying current.next equals rest, and rest.prev equals current. Okay, and so now what do I want to do? Label equals current cups label minus 1. So destination equals current.value minus 1. let's just say while true, if destination is less than one, destination equals 1 million, which is the highest number there. If destination in v1, v2, v3, destination minus equals 1, and okay, and the crab places the cups of pigs so they're immediately clockwise of the destination cup. Okay, and while true of destination goes on elif and then else break. Okay, and now what I want to do is say dest node equals self dot nodes destination, and rest equals dest node dot next, and let's say n1 new equals node of v1 dest node none, n2 new equals node of v2 n1 new none, n3 new equals node of v3 n2 new, and it points to rest, and then I need to fix the other ones, which is that dest node dot next equals n1 new, n1 new dot next equals n2 new, and n2 new dot next equals n3 new. So I think these are probably okay now. Insert the missing nodes. The crab selects a new current cup, the cup which is immediately clockwise of the current cup. Okay. And then finally, self.current equals self.nodes self.current .next.value. Okay. So I think that works. Okay. So now, what does it want me to do? Two cups that will end up immediately clockwise of cup 1. So let me just try this without doing it. Game 2 equals cup game 2 raw for I in range 1 million. If I mod 1000 equals 0, print I, just so I can see how fast it's going. I think it'll go reasonably fast because I'm not doing a million steps each time. And then game2.move. And now what I want to do is say let's say node equals game2 dot nodes 1 and print node dot next dot value node dot next dot next dot value. Okay, and so let's just run this and see what happens. Oh boy, this is really slow. Memory's okay. Let's see where it's at. It is at okay, so there's a bug in that, just as there was in my first one. That's good. Print destination v1, v2, v3. And we'll see how I screwed it up again the exact same way. If destination, maybe I need these in the opposite order. Let's try that. Nope. So the destination is 0. How can the destination be 0? If current value is bigger than 1, else destination is 1 million. Okay. Let's try this one more time. I don't know how I'm so stupid that I can't get this right. Destination is current minus value 1 occurs else 1 million. While true, print destination is not in that. Otherwise, if destination is less than 1, else am I just coming back here, or let me see. No, I'm not even breaking out. So it's 0891. Destination, I'm doing something really stupid here. And what am I doing that's so stupid? Destination is current value minus 1 if current value is bigger than 1, else that. Okay, so print destination, and then assert false. God, I'm doing something really dumb here. What am I doing that's so dumb? Equal to the current cups label minus 1. Current value minus 1. If current value is 1, destination equals 1 million, else destination equals current dot value minus 1. Okay. if destination is in there, def decrement dest, which is an int and goes to int. If dest is less than or equal to 1, return 1,000,000, else return dest minus 1. And so let's say destination equals decrement current value, and while destination in v1, v2, v3, destination equals decrement current value. Let's see if that works. What am I doing that's so stupid here? It has a 1. Five and 10. Okay, so that's not right, but 'Okay, well that's a huge problem that I got the same number twice in a row. So let's think about what I did very wrong here. Okay, so first off, let us, so I think I probably did this right. Find the next def move, current equals self.nodes, n1 equals current.next, find the next 3 nodes, rest equals n3.next, get their values, remove them, current.next equals rest, rest.prev equals current. Okay, so that should be fine. Def decrements, that should be okay too. And insert the missing nodes. Dest node, rest equals dest node.next, n1 new equals v1, v2, v3. Dest node and and then I have to do one more. Rest.prev equals end3 new. Let's try this again. Okay, that still didn't work. Okay, so I'm getting cycles in here somehow, which is bad. So whatever I did it wrong. So find the 3 nodes, get their values. Okay. Remove them. Current.next equals rest. Rest.prev equals current. So I've now detached them, and I found a new destination. Destination node. Rest equals destNode.next, and one new is a node that points backwards at. Am I getting the orders wrong? That would be embarrassing. Prev and next. Okay. And so self.nodes copy of self.nodes prev next self cop. Okay, so that's fine. N1 new is a node with value 1, dest node and no next, N2 new node, N1 new, no next, N3 new is a node with N2 new, and now it's pointing to a node dest node next equals that, N1 new equals that, N2 new next equals N3 new start prev. So that should work. What am I doing? So let's say scene equals set, incur equals game2.nodes, game2.current, for blank in range 1000, scene.add cur.value, cur equals cur.next. Okay, so that's fine. Now let us do a move. Game2.move, scene equals set. Thanks. Let's try it again. Scene is the set. Cur. Okay, we're dropping some now. And why are we dropping them? Scene equals set, cur equals game2 dot nodes game2 dot current for blank in range 1,000,000 cur dot no scene dot add cur dot value print I len scene if len scene is less than 1,000,000 break. So let's try this one more time. Figure out what I'm doing wrong. Seriously? Oh, damn it. I didn't do a move. That doesn't help. Okay, I didn't insert the 3, so now let us let's start adding debug statements and see what goes wrong. I know what's wrong. Okay, good. I need to replace the pointers. Self.nodes and v1 equals n1 new, self.nodes v2 equals n2 new, self.nodes v3 equals n3 new. Okay, and let us just see if it does better this time. Yes, it does. Okay, good. So now I will comment this out, comment this out, and it's still right. What did I do that was wrong? And let's say n1 equals game2 dot nodes 1 dot value, and 1 dot next dot value, and 1 dot next dot next dot value. Alright, so this definitely runs fast enough, but it doesn't do the right thing. So let me make sure. Three, 8, 9, 1, 2, 5, 4, 6, 7, 10, 11. Okay. So now game2.move. And after I move, it should be 2. 2.move 5. And then after the 5, it says I go to 10. And so why do I do that? I do that because I pick up 4, 6, and 7. And my destination is 3. And I place them after 3, so I have 3, 4, 6, 7. And then I go to 8. Because when I pick up 8, 9, 1, and I put them after 7, so I get here, and I pick up 4, 6, 7, and I put them after 3, so they so it's 8, 9, 1, and then everything. And then I put stuff after 3, and that should be okay. Let me do the following. from self n, which is int. Node equals self dot nodes n for blank in range 10, print node dot value end equals comma, and then node equals node dot next. Okay. Let's try this. Okay. And so I'll take 891, move them after destination is 2. I'll take 891 and move them after 2. Now it does. Oh, because I did game.move, not game2.move. Now it's 289, 15, 467, 10. So that looks right. And now I have 5, 4, 6, 7, 10. Let's start over again. So I start with 3. I moved the 891s after 2, and then I moved after 2. Okay, so that's good. I start with the 891s again, and I move them after 1,000,000, I think. So game2.10 from 891. So 891, and then 3, 2, 5, 4, 6, 7. Yeah, that seems reasonable. And now I've gone here. I take 4, 6, 7 and stick them after 3. And then 15, 16, 17, stick them somewhere. I'll stick them after 13, which is going to be back in the past. Let's do that, gonna do that, gonna do that, gonna do that. So that looks pretty, everything it's doing looks pretty reasonable. So did I misread the instructions? $10 million moves. Damn it. Is that the issue? I bet that's the issue. The issue is really that I can't read and I did 1 million instead of 10 million. I'm going to be super pissed. Anyway, let's assume that that's right. And let's see, game 2 equals cup game 2 of raw for blank and range 10 million. If I mod 1000 equals 0, print I, and then node equals game2 dot nodes 1, print node dot next dot value times node dot next dot next dot value. Just thinking real hard. There's probably some kind of optimization I could have done. But I think this will probably work. 2 gigabytes, really? Is that because it's not deleting the ones it wipes out? It should, because they point to each other. Null out their pointers so they can be garbage collected. How do you like that? n1.next equals n1.prev equals n2.next equals n2.prev equals n3.next equals n3.prev equals none. Alright, 10 million, here we come. Nine 34001 and 15. Okay, so those look right. So now let us make sure. Okay, let us try doing it. And let's setting up its million long things, and is that the issue? Is that how fast it goes when it doesn't have to do that stupid thing? Oh no, because didn't I didn't do a game.move. That's the issue. Game2.move. Oh, but then I don't want to take the print statement out. That's why it went so fast. God. Not my day. That is much better though with those deletings. It's going quite a bit faster. So should have done that in the first place. Usually in Python you don't have to worry about managing your memory manually, but today I do. Holy cow, I've been going at this for like an hour and a half. I can't believe that. That's what happens when you make lots of stupid mistakes and don't read the problem correctly. So, all right, one gold star closer. Okay, so the first one I did it with a queue and popping things off. With the second one, that wasn't going to work, so I had to do this. I probably didn't need to do double linked lists. I probably could have done single linked lists. That would have been fine, but I did double, and that caused me problems, and it all caused me problems. Linked lists, I think, were the right thing to do here because they allowed us to solve the problem in a reasonable amount of time, but yeah, you should. Anyway, I'm glad it's done, and I'm unhappy that it took so long, and I'm unhappy that I read the problem wrong, and I'm unhappy that I made stupid mistakes throughout, and I'm unhappy with all of it. So, and I'm too tired to explain it. So, that's well. All right, let me explain. Let me do a little bit. We need a linked list to represent the cycle. Add backlink, add forward link, previous node, add links between and the beginning. Just for debugging. Okay, so find the next three nodes, get their values. Okay, so what do I do in this linked list one? I say I have a current place. I find the next three nodes and then basically the node after that as well. So I should call it N4. I pull out the values. I remove them by saying current, just point his next at rest, and rest point his previous at current. So now N1, N2, and N3 are removed from the loop, but it turns out they still point at each other, and so they won't get garbage collected until I set all of their pointers to 0. This decrement logic caused me way too much grief. I don't know why. And I find the destination, and now what I do is I say, look up the destination, find its tail, and insert these three new nodes in there, hook them up correctly, which is a little bit fiddly, and then advance the current to find the node with the current value. So the other thing besides the linked list was maintaining this lookup table. Basically, given a node I, that means I can find its node in the linked list instantly. Normally, finding things in a linked list takes a while, but if I know that the linked list is all the numbers 1 to a million always, then I can just maintain a dictionary that says, hey, this is the node for node 5. And of course, you saw that I forgot to replace them the first time, so now I replace them. Anyway, it's done. It works. Let us never speak again of day 20.